Hello, .NET Summit, and if we were in the same room, I would probably say good evening. But we are living in a virtual space these days, so I don't know where you are. It may be day or even morning for you. I'm in Oslo. It's plus 25 degrees. Now, just like in Minsk, not like in London when Dylan had his talk when it was 35. And this hour, this is the last talk of the conference. We'll be talking about event journals in Azure, and why did I also explain why I put in subtitle no Cosmos inside. All my talks, they usually reflect some part of project, some part of our internal development, and this is not exception. Actually, we used to have a journal of events written in MongoDB on premises, and so this one came as a relatively small project when we decided to move everything in cloud. And of course, then we faced several dilemmas when it comes to cost, when it comes to features, what to choose. There are several options, and so I will guide you through some of our choices, and of course we'll come to conclusions and show some code on the way. My name is Vagif. I work in I've been living and working in Norway for almost 30 years. Lately working mostly with F#, but today's examples will be presented all in C#. And even though it will be about Azure and C#, actually the main principles which I'm going to talk about, they're relevant for any platform and any programming language. We will start at this with some basic stuff, and then in the end we will go through some examples which we actually extract from our code. So what we will be talking about today: event journals, event sourcing. Like, we'll start with basic principles because it's quite important to stay on the same page when it comes to terminology, to common terms, especially since developers often put different sense in it. We'll touch topics of event-based system modeling and DDD, domain-driven design, even though, as you probably understand, that DDD is the whole separate topic. So we'll just briefly touch it. It's important when you design your events, what you're going to store, but of course we will not go in depth there. Then we'll move to more technical stuff, like how you store, how you retrieve events, how you design your event journals, and how you do it in the cloud with current offerings from different cloud platforms. And we'll finalize the talk by looking at some examples of event journal implementation using Azure Table Storage and Blob Storage. So let's move on. I was somewhat provoked to give such a talk by watching some presentations and reading some articles, which I'd say they demonstrated some excess costs of features when they showed how to build event journals. And I need to explain myself a little. When I'm talking about excess cost, it's cost of cloud resources that can be avoided. Because event journals, they have relatively small requirements to implement. So sure, you can use different storage types when implementing event journals, but how to choose the one which will bring your costs down. And as we will see, the difference in cost is actually quite big. It can be up to 10 times. Then you can also use excess features, because some storage types, they offer you a lot. And it may look like it's not really big issue. Okay, there are some features which we won't need. Unfortunately, developers often tend to use good features around, and so some event journals can actually be implemented in a way that they will sort of have the distorted features. I mean, features that are not really required for event journals, and it may affect the overall system design. We will talk a little bit about that. If we were in the same room, I could probably run a poll about who used or familiar with event journals, with event sourcing, who know the difference between them. But I'm going to address this stuff anyway. So we will start with some basic terminology. So short introduction to the subject. Event journals, it's not the same as event sourcing, but they're often used together. So we will start with explaining a little bit about how you can come to idea of designing system based on events. Event sourcing as its concept actually is quite old. It's older than when Martin Fowler formulated in his blog post, but it became the concept became quite popular, especially since beginning or maybe middle 2000, when approximately Martin Fowler wrote a blog post about it, and he spoke about event sourcing as capturing all changes to an application state as a sequence of events. I must say I find more precise, more deterministic another definition, which was made by Udi Dahan. He made it in his keynote at DDD Europe this year, right before all conferences were banned. And he defined event sourcing as persisting the full history of a domain as a sequence of events, rather than persisting just the current state. That's quite important. So it's not just like we have events in addition to current state. No, our primary source of truth is a full history of a domain, a sequence of events. And of course, when it becomes primary source of truth, it's quite important how to properly deal with that when it comes to performance, scalability, and major system functionality. Still, major part of software systems use databases, use repositories that are based on the principles of storing just current state of data entities and only storing the current state. Partly, it can be because of how they teach databases in universities. It's also very much SQL influence. You have a SQL database, you have various normal forms, third normal forms, for example. Then you have this customer, product, order, and they're all nicely related using foreign keys. And it's very illustrative. Like you look at this table, so you understand how the system looks. And this is how majority of today's systems are designed. And there is nothing immediately wrong about that, but very often handling events in such system, handling happenings, commands, I mean, anything what happens to the system can become complicated. And let's look at a quite simple example. So let's say we have this traditional SQL database, or not SQL, but anyway, where are all entities represented by some sort of tables or documents. You have customer, you have customer address, and this customer address table consists of the following columns, which are on the right-hand side. So you have address type, address, city, postal code, country, and when the address was last changed. So looks like OK implementation, OK definition. Let's think about why the address can be changed. And there may be different reasons. Let's look at two radically different reasons for changing the address. First is relocation. It's sort of normal scenario when the customer used to have former address. Now the customer is relocated, and now he or she is living in a different city, and yeah, we need to change the address. Another one is a correction. So actually, address was registered wrong in the first place. And so these different reasons, they can influence the logic of handling the associated events. Actually, they can imply completely different logic. of handling these events. So in the case of relocation, it's sort of normal situation where if goods were shipped to the former, to the previous address, we don't need additional actions to do that because customer got a new address. Okay, from now on, all new goods will be shipped to the new address. But in case of correction, if there were some goods shipped to the incorrect address, they may need to be returned or replaced. So it's quite different decisions that should be made if we found out that address is corrected. So then it needs to be reflected in some way in the data model. So we need to store information. And what we do, we probably introduce a new table column, change reason, which stores the previous version of data. The problem with that is that this is to be applied to many other columns. Actually, if you are pedantic about our system, then every informational column needs to have a change reason and previous versions of data. So the data scheme becomes overcomplicated. It will combine current state, history of changes, and actually history of changes that are rarely used. So there are only special situations where this thing needs to be used, but mostly we still need to use just current state. However, for the sake of such special scenarios, we need to keep it in the database. So isn't there a better way of doing it? And this is actually what event sourcing can help us with. And there is a related concept not equal to event sourcing, which is called CQRS, command query responsibility segregation, which is when we admit that actually storing just events, storing just history of what happened to the system, it's not necessarily good enough for querying the system, because when we query the system, mostly we are interested just in the current state. So then CQRS can come sort of on the top or in addition to event sourcing based systems that we just realize that no, we just have different data models. One data model is for storing events, and another one which when we query the system. And the term CQRS was coined by Greg Young around 2010, and had a great description about CQRS. He was supposed to write a book about that. It was even announced on Amazon, but he didn't complete the book, but he wrote another book about versioning events, which I think it was self-published. So you will find it, and it's recommended. In CQRS, we separate between sort of write model side of the system and read side of the system. On read side, we are sort of relaxed. We can build as many views as we need. On the write side, we store events. And this is what will be our main focus during this talk. So data storage to record events. Data storage for entity states, which we can use traditional SQL databases for, GraphQL, NoSQL, or their combination. It's all beyond the scope of this talk. So if we apply event source, we may actually need to either refresh or introduce ourselves to domain-driven design, because to correctly select the level of event definition, the level sort of entities where we define events, it requires some digging. And I must say I made personal mistakes in some projects where we defined events on different levels, and it was really hard then to aggregate them to build the state of so-called aggregate root of sort of the main object behind system changes. And there are some examples of aggregate roots where you need to attach events. In finance, it can be like bank account, bank customer. They both can be aggregate roots. So events, it's something that happened to them. Transport, it can be vehicle, it can be vehicle owner. I'm working mostly with broadcasting, with media publishing, and there we deal with transmission channels, TV, radio program, news clips. It's all good examples of aggregate roots. Then when it comes to applying event sourcing, we need to build current state from event journals. It may scare at first glance developers. Okay, how can you build current state of bank account if it has million transactions? And it's possible to use state snapshots for optimization. So we can actually decide that every 100 records we build a snapshot. So you should bear in mind that even though we build current state from the history of events, in no way it limits scalability or performance of system. Actually, very often such event source-based systems, they are more performant than traditional state-based systems because they have very efficient way of writing events. So event journals. So event journals actually are behind event sourcing and don't need to be combined with event sourcing. You can still have event journal without using event sourcing in your system. And this is actually in our project, we have both. We have systems built completely from ideas of event sourcing, and we have, and they're also event journal driven. And we have event journals that are used as audit logs, sort of like we register some events coming from on the message bus from different systems, and we store them all. And we use same journal, event journal types for them. And this is what makes it flexible and interesting with event journal, because same event journal implementation can be used for different domains. So event journals, they have their data schema, but the schema is domain independent. So we don't need to have event journals like for finance, event journals for transport. So we can speak about them in journal terms, and we will do. So minimal event journal schema is actually quite simple. And you will see from in the code that I'm going to show later that it's really simple code because of that, partly because of that. You need to have entity ID. This is your aggregate root. If it's a bank system, then it's probably bank account number. Then you need to have sequence number on some sort of time tag, timestamp. So anything which can order events on that particular entity. And of course, you need the content of the whole of the event itself, the data, associated data, the payload. And the first two fields, entity ID and sequence number, they form a primary key of the event journal. So why sequence number and not timestamp? That's a good question, because it looks natural that like timestamp is richer. Why not just associated time? Well, everyone who worked with time know that working with timestamps, starting with timestamps, the opening can of worms. Well, several events can happen at once. So nothing prevents two events happen exactly at the same time. But the order of events must be deterministic because it can radically change how a system behaves. Then some domains only need event ordering, not exact times. And then having sequence number will be more efficient. Many event source-based systems require quite high level of efficiency. And then why spend this field on timestamp if you don't find just sequence number? But also, actually, if we look deeper into interpretation of time, we will understand that actually time of event, it's something that really belongs to domain, or belong more to domain rather than the actual event journal. Because an event may have several associated time tags. Some domains require to store them all. So if you want to read more about this, you can read about by temporal databases. And they store both time of the event and time of the event registration. Those are two different times. And in some domains, actually, we need to differentiate between them. And if you think it's too easy, then you can read about three temporary databases. Then also store time of the decision. So with that in mind, it's probably easier to relieve event journal itself from interpretation of times and leave it to application developers. So many event journals do exactly that. They use event sequence numbers and they leave timestamps to app developers, who of course are obliged to include them in event payload. So here is an example of event journal from one of the event source-based system. It's akka.net. Akka for Java, it has similar definition for different types of databases. This one is for Microsoft SQL Server. So if you're dealing with persistent actors, This is how they're going to store events for persistent actors. There are several columns, and two of them, you see timestamp and is deleted, that not actually in use. They were declared on early stages, and then it was Akka developers realized that they don't really need them. They don't need this classical timestamp. Even at that time, it was begin, not datetime. So currently, it's a unique key on this journal is persistent ID and sequence number. And of course, the third essential one is payload. There are some others like manifest tags, but they're non-essential. They are just for internal Akka needs. So what types of data store can be used for event journals? As we saw on the previous slide, Akka is using Microsoft SQL Server. It may use Microsoft SQL Server, but actually it has different implementations, including non-SQL databases. So they can also use table store and Blob store. So almost any storage type where you can concept of ordering, which means that except for blob storage alone, can be used. But even blob storage can be used for event journals if you combine blob storage with something where you can take care of order. So any storage that is capable of retrieving data sequentially will do. So you need to define there like entity ID and some sort of sequence number. So today, there are all reasons for putting event journals in the cloud, because storage is cheap. Often when you need to event journals, when it's not event source based system, you only need to store millions of events in your system, then it will be extremely inexpensive for you just to put it somewhere in blobs and table storage and use it occasionally. If your system is event source based, of course, you'll be using it all the time. But again, there are some quite efficient and expensive choices with much better SLA, I guess, than you will have it on premise in your organization. So we limit our scope to Microsoft Azure, but all major cloud platforms offer some storage types that are suitable for event journal implementation. So what options do we have in Azure? We have blob storage, not sufficient alone, can be used in combination with something else. As SQL Server, sufficient. Table storage, sufficient for events if you know that payload has limited size. So single field in table storage can have up to 64K. But you can, of course, you can compress fields, so you can maybe uncompress it with around 1 megabyte, or you can split it into different fields, or you can combine it with blob storage, as I will show in the examples. Of course, you can use CosmosDB, which is sufficient, and it's a multi-paradigm database. So if you're used to MongoDB, for example, that's one of options. We were used to MongoDB, but we didn't choose Cosmos. Later about that. So your cloud storage selection criteria will, of course, include functional requirements. Of course, they will include operational costs, even if you work for paid by customer organization. I guess operational costs are quite sensitive. Performance and service level agreement, don't forget about that. Different storage types can be quite different service level agreements. So event journals and CosmosDB. If operational costs is not a prioritized decision factor, if there are some other important factors that CosmosDB covers, then of course CosmosDB offers great solution, and it has most complete set of capabilities, which include, among others, geo-replication. You have hybrid API supporting popular databases, in case you're already familiar with them. So if you had Mongo on premise, you just change, you move your data and you just change connection string. Reliability of data storage, SLA. All fields, if you store it as a JSON in payload, all fields will be indexed by default. And there are some additional functionality like change feeds. You can subscribe on changes. There are some contrasts of CosmosDB. And first, probably is high operational cost. It can cost up to 10 types, 10 times more comparing to some alternative choices. And it all depends on economical plan. And even if you choose really inexpensive plan, you will find that performance may not be sufficient for you. Performance is great. It can be as good as you might need, but then you need to switch your plan. And if you have uneven load, you will have to switch between different plans often, or as often as you have this change in load. And for event journals, this might look strange, but I found that fields are indexed by default. It's not just no advantage. It can give you some disadvantages. And but before we move to that, don't forget about SLA. For data security and for recovery, Azure Cosmos DB definitely offers more reliable service plan than Table and Blob that we will going to look at later. And if you need multiple region redundancy, high throughput, minimal latency, and so on, then consider Cosmos DB, or at least read through its database service level agreement. It's quite comprehensive on Microsoft site, actually in different languages, and you will see it offers a really great SLA. So what can be wrong with such great feature of Cosmos DB as indexing all fields? In addition to performance aspects, like reduce write performance, increase size of the storage, actually, I believe that can lead to wrong architectural choices. Because what may happen is that you can be fooled by thinking that, okay, let's store events as we store them in JSON. We put them in payload as JSON, and we will index them so we can effectively query directly in the event journal what we need to get on a query side. So it contradicts the CQRS principle, which I think is quite important to follow when choosing at least event sourcing approach. So I would compare it with if somebody said that, okay, let's make all fields in C# and Java public, fields and properties, so they can be accessible for possible future scenarios. So we may need this field, okay, but it's already public. And do you agree with that? A good idea? I guess not. So the same logic can be applied to like indexing the content of journal events, because event journal records, they contain completely events from completely different sources. So it's a mixture of apples, oranges, or maybe meat and fish. So why should we index completely unrelated things? So just don't do it. Take event content as opaque as Blob, and just don't take these additional advantages, even if you have it from your storage type. But when choosing table blob storage, remember, no georeplication, brutal consequences of unintentional deletion of data. It can be easily solved by using ascopy, for example, but you have to think about it. Just remember that if somebody mistakenly delete all your tables, then there is no way to recover if you yourself don't take care of it. And also it has just single service plan. You can't have the multiple service plan with better throughput. But I must say that Table Blob offer excellent performance. If you read Troy Hunt's article about how he built database of stolen passwords, he was using table storage, and I think his write performance was about 20,000 records a second. That's astonishing. It has some limitations, size limitations. As I mentioned before, maximum field size 64K, maximum 16 fields in a table record, but we don't need that many, as you know that event journal really needs just 3 main fields: entity ID, sequence number, and the content of the event, and maximum record size 1 megabyte. What we do, we compress the content so 97% maybe of our data of our event content is compressed down to less than 64K. And if you have really large events, you may also revise. You may think why you have them, because those which actually, that's 3% in our case, that don't fit. I guess we made some wrong design choices when we defined the events. But anyway, the choice was made. Now we need to take care of it. So we just put them in the Blob store. If you want to store your data asynchronously, then you can use Azure Cloud Messages, Cloud Queue Messages. Queue Message also has a restriction for 64K. And if it's not sufficient, you can use Service Bus Standard Message, which is 256, and Azure Service Bus Premium Message, which is up to 1 megabyte. When it comes to costs, here's one of the calculations that we made while making the choice between CosmosDB and Table and Blob Store. And that was one of the primary arguments for us to choose Table and Blob Store combination. So rough estimates, we ended up with about 10 times difference between combination of Table Blob and CosmosDB. So it's big enough. It's too big, actually, not to take care of, not to think of. But does Table storage fit event journal requirements? Well, yes and no. If you remember our definition of event journal, what it requires, it looks like it fits, because it only has event journal only requires one indexed compiled key, which is sequence entity ID plus sequence number or timestamp. So for such an academic event journal, that's sufficient. But what if we need to replay events in a time interval across all entities? And this is not classic scenario for event journal, which is behind the event source-based system. But what we experienced, for example, is that there was a system outage. We lost some data from external system. So actually, we needed to replay all events within a certain time interval, within 3 days. And without index support, that's not feasible task using table store, where you only have index by entity and sequence number. That's your only index, because the table has just one single clustered index, and we dedicated it to entity ID and sequence number. So how can we solve it? There are some workarounds. So you can still use table, but you need to do something smart. Because you can create 2 tables per event journal. It will work. It doesn't feel elegant. Probably we developers should be practical, don't think much about elegancy. But we went for what we found aesthetically more appropriate, creating hybrid index. So it's the same table, but we use so-called inter-partition secondary index pattern, which is described in Microsoft documents. So Microsoft actually had, in some scenarios, similar requirements, and they're dealing it by sort of putting 2 indexes in single clustered indexes, because it consists of partition key and row key. And you can, when creating partition key, you can prefix it with index type. Like in this example, taken from Microsoft article. If you want to be able to sort customer, to look up customer both by employee ID and by email, so you just create 2 different partition keys, one prefix with emp ID, another one prefix with email, and you are able to look up and sort your data accordingly. So this is what we did, and this is a screenshot from our data. You have on the right-hand side, this is our primary index partition key, which consists of prefix ID and entity ID of TV or radio program. On the left-hand side, it's date and actual day. So additional key is we attach to every record is the actual date when this TV or radio program was created. To show you how this works in practice, I created example which is based. It's not equivalent. It's not equal, but it's equivalent to what we're actually running in production. You can find it. It's a public repository. You can find it in my GitHub account. So how we used Event Journal and using Azure Table Blob Storage to implement Event Journal in the cloud. So there are 3 levels of these examples. Actually, this is also what happened to us in our project. First, we made a basic version where application had to make direct call to a custom library. It's fine, but I mean, anyone who wants to write something in Event Journal need to reference our custom library, and it can be simplified. And also we can improve scalability of our system by doing this asynchronous write. So we implemented this cloud queue version. So instead of writing directly to Event Journal, applications just write to queues using Azure Queue Storage. And later, this when message is fetched from the queue, it's written to Event Journal. But later we came with 3rd level, serverless. Application just makes an HTTP request, usually HTTP post, and which sends event to Azure function. And so we use Swagger to document our API, and this is how currently it's used by most of our applications. So we'll start from the top. This serverless function. So there's a function, Azure function called enqueue, where we define HTTP verb post. We define route, which consists of HTTP path, including version of the message and collection name. This is the body of this method. So you see, it's quite simple. We just generate a queue name, we log what we're doing, and then we create, if the queue doesn't exist, we create it, so it's done only once, and then we create message body, message that will be queued, and here we use just classic JSON. We serialize it, we zip it, and then serialize to base64 string and send to queue. And of course, there is some exception handling here, but I skipped it for the sake of brevity. So this is send to queue async, which actually is how to send a message to Azure Cloud Queue. So it's just 4-liners. You're creating Cloud Queue message, and you call add message async. So it's as easy as that. And what happens then is this queue message triggers another piece of code, which here's a queue trigger, where we define action on the message arriving to the queue. So here we're supposed to write the message to the storage, to the actual event journal. So first we do the opposite. We unzip this message, so we get the original message, and then we save it to storage. Save to storage, it's our function, save to storage async, where here there is quite simple code. You see, we even though event journal requires 3 main fields, we also have some additional fields like description, for example, because we have like 16 fields totally, which we can use in table store. So we just extended metadata, which we store together with the event. So again, we zip it and we save to storage. This is another method which is called, which takes as parameters table and blob container. And this is because the length of the message may exceed max table content length, which is 64K. So if it doesn't exceed, then we just write to the table. If it exceeds, then it's 2 lines of code, obtaining block reference, and upload from stream async. We upload the content there. And in either case, we write something to the table. We call all metadata, and content, if it's small enough, is written to the table. So we need to create partition key, row key, and we use standard Azure Table API, table execute async insert. And creation of partition key is up to you. It's basically up to your domain. So we normalize ID, and we use ID key prefix. As you saw, we have ID for primary index, and we have date for dates. And we create row key. So that's basically it. If you look at the repository, you will find more code there. But the essence of what is done to implement event journal is exactly what I show you. So it's quite simple, and it's very performant. Since we still have about like 5 minutes, few words about adding Swagger to that. So it's quite simple. It's just to add some custom attributes to your C# code. And what I found was at the time of writing, there was no Swagger support for Azure Function version 2. What I found is a NuGet package, Azure Functions Extensions Open API, written actually by South Korean developer. So it's probably the first time I used in my development NuGet packages which comes from South Korea. I guess it should be okay from security point of view as long as it's from the south of Korea. And this is some extra stuff which I had to add. Everything which starts with Open API operation, Open API parameter, Open API request body, it defines some metadata which I use to generate Swagger page. So after I did that, so here is how my Swagger page for the function looks. So everyone who worked with Swagger knows that it's really worth. It's totally worth to add Swagger support, because you can look at documentation of your function and you can actually execute directly from this page, sending data to the function. So to conclude my talk, event journals are very important if you need to register precise information about times and reasons for system state changes. If you only register current state of the system, you will keep on losing important information which may bite you later. And all modern cloud platforms offer everything to build or relocate event journals in the cloud. So there are no reasons, unless very special reasons, to keep your event journals on premises. And there are simple and inexpensive cloud storage types, and they're all sufficient to implement event journals. So you don't need to go for expensive storages, but you may choose them for reasons that are different than core event journal requirements, like, for example, to meet high level of service agreements. So with that, I think I'm finished with my talk. If you have questions, you can ask them now, or you can find me on Twitter, or you can mail me. And thank you for organizers for having me on the conference.
Thank you, Vagif. It was a very good talk, very interesting.
Thank you.
And since I don't see any questions in the chat, don't think that it would be an easy ride. I have a question for you. With all those event journals, the key point for me is an ability to rebuild the current state if, for whatever reason, we lost it. So, two questions here. First, am I right here? So, could we use event journal in general as the tool, the source of data to rebuild our current state? And second question that will be followed: have you ever done that by yourself?
Yeah, thank you for the questions. Yes, the answer actually yes on both questions. As I mentioned in the talk, event journals can be used both for storing audit of the system. In that case, it's something that is not built as event sourcing kind of system. So, and we have in our organization, we have systems like that. Just to give you a quick example, what we built the current state is a TV program, which includes a lot of associated data in addition to actual media files. It can be subtitles. It can be information about actors, about geographical places which program is about. And all this comes from completely different systems. And so all this goes to event journals in the cloud. And actually my talk basically shows a part of that system. And this is not used to build current state of the system. This is used just as a history of what happened. And a couple of years ago, we had a quite big data crash. So we lost current state of the system. Luckily, we publish upfront content of TV radio programs which go and air if it's not direct programs. So we had some like 3 days in advance to fix it. And there we have to replay our event journal. So we use it as this audit log, which was replayed to build the current states. But the second type of system is actually systems that based are event sourcing, and they have no other persisted state except for what is coming in form of events. One of such systems is based on akka.net, and it uses persistent actors. And I showed in data schema for akka persistent actors. There, the primary source of truth in the whole system is what is stored in this persistent actor state. And for optimization, there are some snapshots that periodically are taken, so we don't need to rebuild the whole state continuously. But yes, we actively using such approach, purely event source based approach, and it works very well.
Thank you. That's actually very good to hear, because seeing that real life applications of the concepts like that is very helpful to be able to push them through the company. We have a couple questions from the audience. That's good. Mm-hmm. What about replication of event journal to support low response latency in several regions?
It all depends on your performance requirements, scalability requirements. In our system, we don't need such requirements. So it's fine for us to use table store, which don't have geo-replication capabilities. But as I mentioned in the talk, CosmosDB actually is great for if you have such requirements. And even though my talk was about event journals with no Cosmos inside, if geo-replication is important for you, then this is actually a situation where you will probably end up with event journal with Cosmos inside, which will be geo-replicated.
That's good. Second question. Have you integrated the event journals with any third-party reports, for instance, the integration with Power BI? How you consume the event data collected in Azure Cloud?
We didn't integrate event journals with Power BI, but I think that here what should be applied here is this CQRS approach. So event journals is W of secure of this write read we have this, and this W write, it's event journals. So what our system are implemented with eventual consistency in mind, which means that we store events and commands in event journals, and whatever needs we need to query the system, whether it be Power BI or something different, then I would never do it directly by querying event journals. I would rather add functionality that will synchronize content of events with something else. Actually, we did it recently with our Akka system. There was another group development team that asked us to get access to states of our actors, and we have that. So we can query directly from event journals the state of our persistent actors, but that's against this CQRS principle. So, and actually it also comes with a cost of performance, because our Akka system is cluster based. So every time somebody asks about state of some actor, we need to go through the cluster and find the node which currently owns this, which hosts this actor. So instead, we on every change to the system, we write in regular SQL database snapshot of the state of this actor, so they can be independently queried. And then, so I think that this is how I would go with regarding integration of event journal with some other extra system. It's just a read part of the system, and it should be mixed with event journals for direct querying.
That's actually very good and thorough answer. Thank you for that, Vagif. And I believe we're done. We are going to close this great conference. Thank you, Vagif, and thank
you, everyone.
Join us on the closing ceremony, please, where we'll have our we have a couple words to say to you guys, and after that there will be an after party, and we will post a link to that in the chat on the closing ceremony. If you want to join us and to talk with us and probably with speakers, join there. Thank you. See you on the closing ceremony.
Thank you very much.